How to make better castings through proper sprue and pouring basin design.
I thought while I was at making these moulding box sides, I'd show you what I consider to be the easiest and best thing you can do to improve your castings. It's very simple, and it amazes me that people don't do it more often. It's nothing really new. Part of it's been known since probably about 1900 and part of it since the mid-1950s. But here's the trick. First of all, what happens here? A lot of people, when they pour a casting, and let's say here's our mould sitting here, with our cavity in here, perhaps, and well, they decide they're going to put a nice big sprue down here. It's inevitably a parallel-sided sprue, and it's usually at least 25mm diameter or more, and they'll have some sort of a gate there, I guess. And when they pour it, a little stream of metal comes down and it splashes all over the place down here. It mixes in air. In fact, it sucks in air, just like Venturi's do. The moving metal stream actually pulls air in, so you're constantly getting air mixed in your metal, and you wind up with metal with oxide films all through it in your casting, and it doesn't make for a very good casting. Some people even make it vastly worse than this. If it were possible, they get something like this, a bean can. They fill it full of sand, and they cut another hole. It usually doesn't match very well here, I note. And they put some sort of funnel in the top of it like this. And now the metal falls even further. It's even more turbulent. It sucks in even more air. It makes an even worse job of the casting, and really add insult to injury, the extra pressure when it's full pushes the metal more into the sand and gives you a rougher casting. This is absolute rubbish, and you should never do it. Now, here is what you should do. You use a tapered sprue. This is the shape that water falls out of a tap, and you can confirm that by yourself just by turning a tap on. Mould sitting here. Casting over here, let us say. Other half of the mould down here as usual. Now, you cut yourself a pouring basin, vertically sided. And you pour your metal into there. This ridge stops metal from here going straight down like that. So it slows the metal down a little bit, which we want to do. But as soon as the metal fills here enough to get over the ridge, it will fill that sprue, and that sprue will run full for the entire filling of the casting. That means it cannot suck in air, and we get clean metal delivered down to here. And you fill the basin. I actually fill the basin up to about here while I'm pouring a little bit over the top of the mould. And this works much, much better. Now, over the years, I've made a lot of tapered sprues up. Here are a few. Quite a few, in fact. I've experimented a bit. That's actually the one I use most now. It's 5/16 of an inch or 8mm diameter down there at the bottom, and it's about 13mm up there. It has a taper on the side of 1.4 degrees per side. Unfortunately, there is no universal taper. The taper required varies as the size of the job, the size and shape of the sprue, the height of the sprue, and all sorts of things. But it is possible to calculate it, and later in another video I might show you how to do that. Now, many people, when I show them a sprue like this, say, "Oh, my castings would never run if I used that. Oh, no, terrible." Rubbish, absolute rubbish. I've poured tens of thousands of castings with that very sprue and they have all run. Now, I say to people who pour using this system to count the number of seconds it takes them to fill a mould, and I will back it in that it's about the same number of seconds that I take using this. The same number of seconds is going to fill the cavity in the same way. So, alright, how do we actually cut this basin? Let's have a bit of a look. I'll just clear up here a little, get rid of some of the excess here. Right, first thing we do is we strike the mould off, pull out the feeder, oh, excuse me, by rattling and wobbling it, pull out the sprue just by twisting it. Don't wobble it. If you wobble it, it tends to do this and it makes the bigger down the bottom than we want. We want that bottom small. Now I like to, at this stage, just put a little bit of part down these holes and then blow it around with a bit of air. Because that nicely coats them on the inside with a bit of part, so any sand that falls down is not going to stick as much. Now, alright, having done that, let's strike the mould off level. Notice I pull those out before I strike the mould off, because it's an awful lot easier than trying to strike the mould off when they're still there. You just have to work from the centre of the big holes. Now the other side of the blade. And there we go, not too bad at all. Now, I might just move the camera so that you can get a somewhat better view of this. I hope this is going to give a reasonable view of the cutting of the basin. Now I cut this with a thin walled tube. This is about an 1.25 inch tube. It's very thin and that seems to help a lot. I've got a bit of a vague mark there as to how deep I want to push it in. In fact, I'll probably push it a little further than that. About there maybe. And I'll come about there, I guess. Just push it straight in. Hold the outside bit best we can. And that gives us a nice sharp edge. Tap this to get the sand out and that's away. Now, basically this is a connecting the dots scenario at this stage. But the important thing we have to do is leave a ridge between this basin and the sprue. That ridge is very important. And I know when some people try this, they make the mistake of making the ridge much too high. The ridge wants to be no more than 5 or maybe 10 millimeters above the bottom of the basin. Some people have got a bit confused and made it from the top of the basin down. No, 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 not good. That's getting pretty close. Now there are a couple of things that are important, if I can just get back to my little diagram. This radius in here. If you don't have a radius there, if you have a square edge, you will get an air trap in there. Similarly, you need a radius there. Nice if you can get one here too, but not so important. That can be straight down. If you have a square edge here, you will find you get an air trap in there, and this will bleed air into the casting for its entire filling time, or at least about half of it. So we must have this radius smooth. This side here, that does not matter as much. That can be almost vertical. I like to put a bit of a rad on it, as you'll see in a minute. Now I simply do these radii using a paintbrush. Oh, there we go. If I get down in here and just round out that bottom edge. I do seem to have a bit of a lump in the middle of that. That's got it a bit better, maybe. That looks not so bad. I'll just round that edge a little. Get my brush. It's just putting a bit of part on this brush. It just seems to help a little. Don't know why, but it does. Now you'll note that I've done nothing to smooth that basin itself up. I've left it quite angular on the bottom, and that's deliberate. The worst thing you can do, come back to here again, is to cut a basin that looks like this. Because if you do, the metal will hit that and ricochet right out like it's water hitting a Pelton wheel bucket. Keep the sides vertical, edges almost sharp there. You can have a little radius there if you like, but it doesn't seem to matter if you don't. Alright, I'll pull this mould apart and we'll do the next bit. That looks pretty good in there. Now, I'll just move the box a little so I can get the other bit I want here where we need it. All these boxes are so damn heavy for an old fella like me. Now there, I've made a mistake. I've put my thumb in there and hit that bit of the mould. I think we've managed to repair that with that. Get some air and I'll just blow out the sprue. Get my little brush again, wherever it's gone. Here it is. And I'll now just radius the bottom edge here towards the feeder. So I've got a bit of a curve there that hopefully the metal will go around without trapping an air pocket. I might even on this occasion just take a little bit of sand off that too. Okay. Using my thin-walled 1 1/4 OD brass tube and this sort of guide. You don't really need one of these guides, but it just makes it a bit nicer to make the top edge of the basin a bit nicer. I'll now cut the basin proper. Push that in to a reasonable depth, pull that out through there. Tap that just to get the sand out. And using my trusty cut down spoon, I will now join the dots to finish the basin off. It's just a question of blending the small hole to the big hole, really. Sand out of the way so I can see what I'm doing. You have to leave a ridge between the two holes. This is most important. In fact, it is of critical importance. The ridge should be between about 5 and 10 millimetres high from the bottom of the basin. Now, some people have misinterpreted and have actually made the ridge 10 millimetres down from the top of the basin, which is much too high, of course. Just smooth that up a little. That looks pretty good. The really critical thing here is that this junction of the sprue and the ridge top is well radiused. That's not too bad. A little bit of a radius on the basin side of the ridge, but that's not so important. Blow it out, and then we're done. Oh. Well, we'll smooth that up a little bit. We seem to have got a bit of loose sand out of that. Right. We're done. Not too bad at all. Again with the thin-walled brass tube. Push the bowl of the basin down. Pull the tube out. The idea of using this is just that it holds a nice sharp edge when you pull it out. Just makes it a bit neater. Don't really need to use that. You can, if you wish, you can just grab the tube and push it into a certain depth, rattle it around a bit and then pull it out, but sometimes it doesn't quite come out as neatly. Yeah, lost a little bit. But you can do it that way, just as easily. Now, where's my little carving spoon? We join the two dots. We blend the sprue to the size of the basin, cutting away most but not all of the central ridge. We want to leave a ridge about 5 or 10 millimeters high in between the basin and the sprue. That's probably pretty close. Just even that up a little maybe. It looked a bit uneven there. Now the critical bit. We must put a very good, generous radius at the top of the sprue where it joins that ridge. That's very important. A little bit of a radius either side maybe. Quick smooth around the top. And there we go, job done. Always remember when you're doing this to check to see that your sprue is clear. Sometimes it blocks with the little bits of sand that you cut off and get blown around. So just always make certain you can see through the sprue before you actually finally close your mould and pour it. Well, that should do it, I hope. Part of the trick here is to put the pouring basin as close to the edge of the box as possible. The reason is that this allows me to get down here with the ladle below the top of the box, so that most of the ladle or crucible, and in fact the metal in it, is right down below the top of the box. That means it's very easy to hit that target. Much different situation if I was trying to pour into that hole. I'd have to be way up here and I'd be all over the place. But here, much easier. So we'll give this one a bit of a go and see what happens. The idea is to fill the basin as quickly as possible, and that means the sprue fills as quickly as possible. So we throw it into the basin and there, it's full and it's flowing nicely, and there we have a full mould. Down low, straight into the basin, it's full, and now so is the entire mould. Ladle right down below the mould. In we go, full. Sprue's full, and the mould's now full. Full, there we go, straight away. So I'm actually tending to run the metal a bit above the surface of the mould. And there we're done.
Let's now have a look at those pours in slow motion. I've slowed them down to 1/10 the speed. As you can see here, I've got the ladle as low as I can get it to the top of the mould. I'd like to get it even lower, but you just can't do that. Now, the metal hits the basin, and very quickly it comes up over the ridge, tops the ridge, and fills the sprue. Now, one thing to watch for here is that shortly into the pour, it inevitably, the metal flow down the sprue speeds up and the level in the basin drops. You've got to be ready for this. At this stage it's dropped quite a lot, and we rather need to keep that flow up, for as you'll see in the next version of this, we don't quite make it, and it's got quite low there, but it's still covering the sprue, so we are in fact okay. Why does this happen? Well, when the metal first starts going down the sprue, the sand is cold. So some of the metal in the sprue actually solidifies. There's a sort of a shell, if you like, where it touches the sand. However, once the sand is warmed up by this, it loses its power to chill the metal further, and further metal coming down the sprue remelts that originally solid ring. The result is that the flow speeds up. Now, slowly as the mould fills further, of course, and begins to rise up the feeder, the available head becomes less, and therefore the metal slows down again, virtually coming to a halt right near the end, of course. Now, the interesting thing to look at here is the metal stream itself coming from the ladle. You can see it moving around a little bit, it's wavering, it's wobbling, but it's not actually flowing. What's happening is that the metal is flowing through its own oxide skin, and that skin is protecting it. And you'll see that again in every one of these pours, and it is the way to do it, but you must not break that skin. Here I make a mistake. It gets too slow. And here in particular it gets way too slow, and I think the top of the sprue is actually exposed. It may have drawn in some air doing that, but hopefully not too much. That's about the level we'd like to have it at in the basin all the time, but it's not easy to maintain that. It takes a bit of practice. That was not my best pour. Note the splash when it first starts. You can't do much about that. It's more or less inevitable. The only thing you can do is get the ladle or the crucible as low as possible to the top of the basin so that the splash will be the minimum possible. This so far is a better pour, but again it's starting to drop a bit. And again you can see the metal is running through its own nicely protective tube of oxide. Providing that oxide does not break, none of it will get down into the metal flowing into the casting. This is a much better pour. You can make it a bit easier to keep up with if you use a bigger basin or a deeper basin, but then it takes a bit longer to fill, and of course you use a bit more metal up. But it's nice clean metal coming up in the feeders, nice shiny. Again the initial bit of splash, but this is the best pour. It runs just about full all the way. This is really how you should do it. I like to keep them a little over the top of the mould. The metal is sort of sitting there on its meniscus a bit. Again, it's backed off a little as the flow speeds up, but I've caught up with it here, and we've managed to not let it go much lower than this at all. In fact, now it's come back up to a bit above the top of the mould, where I like it to be. This is the best possible thing you can do to improve your castings. If you're not using a pouring basin and sprue setup, something like this, then you can do better. Here we go, full again. Thank you for watching, and I will do that follow-up video if enough of you ask me to do so in the comments below.